Okay, we start from the very beginning. Limits. Now, do you guys remember right before we went to vacation, we did L'Hopital's rule?
Yeah.
You know, if you know L'Hopital's rule, you have such an advantage over other people. Okay, what is the limit as x approaches 2 of x minus 7? What's the first thing you do with a limit problem?
Plug it in.
You plug in the number. If you can plug in the number and get something, that's the answer. So if I plug in 2, you get 8 minus 7? 1. How many of these you can see on the AP exam? 1. No, none. Okay. What is the limit as x approaches 2 of x squared minus 4 over x minus 2? What happens when you plug in the number?
0 over 0.
You get 0 over 0. Now, what do we call a limit that comes out either 0 over 0 or infinity over infinity? Indeterminate. So what you can do, there's several things you can do. One is you can try and simplify it like this. Woo! Now can I plug in 2?
Yeah.
Then you get 4. Or you can use L'Hopital's rule, because L'Hopital's rule works when you have 0 over 0 or infinity over infinity. So if you want to use L'Hopital's rule, then what do? What does L'Hopital's rule say? If it's 0 over 0 or infinity over infinity, you take the derivative of the top, take the derivative of the bottom,
1.
now plug in the number. Or, and you got the answer. That's why a lot of students, they don't get the L'Hopital's rule, and then you're at a disadvantage, because L'Hopital's rule can bail you out in lots of situations. Especially, what about this one? What's the limit as x approaches 0 of sine x over x?
1.
Now, you're supposed to know that this is spread, this is 1, but let's say you forgot. 0 over 0, so you use L'Hopital's rule. So take the derivative of the top. The bottom. Now plug in the number. 1. You don't know anything if you know L'Hopital's rule. You got to know how to take derivatives, though. Because if you don't know your derivatives, then you can't do it, right? No, well, I would like for you to know friend. I would like for you to know friend. But if you don't, like you're pressuring out of the test, just use L'Hopital's rule, right? What is the limit as x approaches infinity of 2x plus 3 over 5x plus 7?
2 fits.
Now, I would like for you to just look at that and go, okay, 2 fits, right? Because as x approaches infinity, in other words, as the graph goes out to the right, the y-coordinates are getting closer and closer to whatever the horizontal asymptote is, right? And what are the rules for horizontal asymptote, which is in your notes? If the degree of the top and the bottom are the same, you look at the coefficients. 2 fits. However, if you don't remember it, just use L'Hopital's rule, because if you plug in a really big number for x, that's really big, so it's infinity over infinity. What's the derivative of the top? What's the derivative of the bottom? So you get 2 fits. And same thing, if the what happens if the degree of the bottom is bigger? 0. What happens if the degree of the top is bigger? Then infinity will be either infinity or negative infinity, depending on the coefficient. Yeah, you don't need to know Apple anymore. I would like for you to know Apple. Now here, that was my next thing. What's the limit as x approaches infinity of x squared over e to the x? You know, both the top and the bottom are getting bigger, right? But which one is getting bigger? Well, if you remember Apple, this is exponential, polynomial, logarithmic, right? Logarithmic function, here, I'll draw. Exponential functions go to infinity very quickly. Polynomial functions, like x to the second, x to the third, go to infinity, but not quite as fast. And logarithmic functions, they go to infinity, but very slow. So this is a polynomial function. This is x goes to infinity faster. Exponential. So if the bottom is growing faster than the top, what do you think the limit is going to be? Yeah, 0. And what would happen if the top is growing faster than the bottom? It would be infinity, right? However, you don't even have to know that if you know L'Hopital's rule. Okay, because this is infinity over infinity, so you take the derivative of the top. derivative of the bottom, and it's still infinity over infinity, so you do L'Hopital's top, take the derivative of the bottom. Can I do L'Hopital's rule one more time? No, because it's not infinity over infinity anymore. You've got to figure out the limit right here. Well, if you plug in a really huge number, you get 2 over e to the really huge number, which is even huger. So 2 over gargantuan is close to 0. So the limit is 0. But wouldn't it be a lot easier just to know FO and friend? Now, yes, you guys can compute limits, but you guys got to understand what limit means. Because they're going to ask you it in a, like, they might give a multiple choice, they might give you a picture like this. Woo! Woo! Yeah! Okay, here's a function. What is the limit of this function as x approaches 2? Or is it 3? Remember, in order for a limit to exist, the left-hand limit and the right-hand limit have to be the same. In other words, it has to approach the same thing from the left and the right. Are they? Yeah, and they're both. So what is the y-coordinate of this point that they're approaching? 3. That's the limit. In order for a limit to exist, the left-hand and the right-hand limit have to be the same number. Because what if the graph looked like this? Here's 2. What if the graph looked like this? Woo! What is the limit of this function as x approaches 2? Okay, here, let's put, this is 1 and this is 2 then. The limit does not exist because the left-hand limit and the right-hand limit are different. So they might ask you, okay, what is the limit as x approaches 2 from the left? They might ask you that. What is it? Well, coming from the left, the graph is getting closer and closer to this point. What's the y-coordinate of that point? It's 2. The limit of this function as right 1. So therefore, what is the limit of this function as x approaches 2? Does not know. Does not exist. Now, on the AP exam, if you're on the free response section, I already told you guys this before, you cannot make a legend on your paper, then you can abbreviate. Yeah, but why you want to make a legend? Because usually it's only going to show up once, right? Just write it out. Like remember, F is concave up, F is concave down. Remember all that stuff?
3D. 3D sphere.
Okay, that's limits.
As opposed to a 2D sphere.
Okay, now after we study limits, what do we study next? The derivative. Now, what is the definition? Now, you guys know how to compute derivatives, right? Product rule, quotient rule, power rule. Okay, but you got to know the definition of the derivative, which is
The
this.
slope at a point.
No, that's not the definition. The limit as h approaches 0 of f of x plus a. Believe me, they're going to test you on this.
Minus f of x all over h.
Yeah, anyway, this is going to be on the final exam. Remember the thing I thought, this is one of the 50 problems. So you're going to see this equals blank. Sorry, I already showed you already. It's f prime of x. It's the derivative. So how do they test you on the derivative? Anyway, you know what? I should tell you this. No, I'm not gonna.
You should tell us.
No, I'm not. We got time limitations here. So, on the AP exams, usually multiple choice, you have this. Limit h approaches 0. In fact, as soon as you see limit h approaches 0, you should be thinking, hey, that's the definition of the cosine x plus h minus cosine x all over h. What is this equal to? So the first thing you go, hey, that's the difference quotient.
Sine x.
The limit as h approaches 0. What function am I taking the derivative of? Yeah, right here, because look, this is f of x. This is f of x right here. So this will just compute the derivative of cosine x, which we know is
Negative sine x.
negative sine x. Boom, done. But you have to recognize it as the definition of the derivative. Okay, now what happens, like if you have an x right there, it's very easy to do. Okay, but what happens when they have a number there? What is the limit as h approaches 0 of tan inverse 1 plus h minus tan inverse 1 all over h. You gotta go, A. As soon as you see limit h approaches 0, this is the definition of the derivative. What function am I going to take the derivative of? Your eye should go right there. Tan inverse, no. Tan inverse x. Not tan inverse 1, because the derivative of tan inverse 1 is 0, because that's just a number. The derivative of a number is 0. The function you're taking the derivative of is tan inverse x. So what is the derivative of tan inverse x? What's the derivative of tan inverse x? 1 over 1 plus x squared. Okay, so if
So that should be an X,
Go ahead, look.
right?
if there was an x here, then your answer would be 1 over 1 plus x squared. But there wasn't an x there. There was a 1 there.
So tan inverse 1 is just pi over 4.
No. This means you're computing the slope of the tangent line when x is 1. At a See, this just tells you the general derivative, which tells you the slope at any point. But this is computing the slope at a particular point when x is 1. So, yeah, you just plug in 1 for x in the derivative, and you get, what happens when you plug in 1 there? You get 1/2. Get it? You plug in this number into the derivative. You have to take the derivative first, and then plug in the number. If you plug in the number first, then the derivative of a number is 0. You guys get it? Now, if you look on your notes, there's another definition of the derivative. So, to compute the derivative at a specific point, there's 2 definitions you gotta know. One is the one I just showed you. The limit is h of 0, f of a plus a. A is just a number. But there approaches a. F of, you guys don't have to write down anything. This is all in your notes. Just look at your notes. You know what you should do? You should look at where on your notes it is, so you know where to look. Don't write down. Don't write down. Down. So on the multiple choice, this is what you can expect. Limit x approaches whatever. Give me a number. 2 f of x minus f of 2 all over x. Look at here. And then they might give you a picture. See, you got to put things together. So here's 2. So they could give you a graph like this. Ooh. There you go. Okay, here is the graph of the function y equal f of x. What is this equal to?
0.
Well, first of all, what is this? Hey, that's this thing right here. That's the definition of the derivative. This is equal to f prime of 2. And what does f prime of 2 mean?
The slope at that.
Yeah, what is the slope? Remember, derivative means slope. What is the slope when x equals 2? So here's x equal 2. What is the slope of the graph right there?
0.
0. So that's 0.
That's right.
Woo. You got to put things together. You know what I'm talking about? Derivative tells you the slope of the tangent line. All the derivative tells you is the slope of the tangent line. That's all it tells you. Okay, so you guys can do 1, 2, 3, 4. What do you do when you see absolute value, like in problem number 4? Make a piecewise. Do we have to review that?
No.
I think we do. According to the definition, the absolute value of x is equal to x when x is negative x when x is less than 0. If the inside is positive, you leave it alone. If the inside is negative, you negate it. So, okay, let's do a simple problem. X minus 1, x squared minus 1 over the absolute value of x minus 1. Like how would you even start to graph this function? Start plotting points. No, you make a piecewise function. Okay, so here is the absolute value. What makes the inside of the absolute value 0? 1. So x is greater than or equal to 1, or x is less than 1. How come I don't put the or equal to? Because it makes the denominator 0. Okay, now, if x is greater than 1, isn't that thing going to be positive?
Yes.
So leave it alone. See, whenever you have an absolute value, it's either equal to itself or the opposite of itself. Okay, so if x is less than 1, then the inside is negative. So what do? Use this one. You negate it. See how if the inside is positive, you leave it alone. If the inside is negative, you negate it. Then do you notice that this can be factored as x plus 1 times x? Oh, they cancel. So if you were to simplify, you would get x plus 1 when x is greater than. Same thing here. This can be factored as x plus 1 times x minus 1. Cancel. Negative x minus 1 when x is less than 1. So if you were to graph this, these are just lines. You're expected to graph lines and parabolas, sine, cosine, x cubed, and so forth. Okay, so when x is 1, you get 2, and the slope is 1. When x is 1, you get negative 2, and the slope is negative. The graph looks like this. Remember how to graph piecewise functions? So let me ask you a question then. What is the limit of this function?
Does not exist.
Yeah, because look, here's one here. Coming from the left, coming from the right. Is it going toward the same point? No, so this limit does not exist. I can write that because I have a legend. I always have the legend. You guys don't have the legend yet. Yeah. Yes. Does not exist means it doesn't exist. Undefined means it's not defined. Like, okay, like here, 2 divided by 0, that is undefined. A limit, though, there's no such thing as a limit is undefined. A limit doesn't. And the only way a limit can exist, like I told you, it's got to approach the same thing from the left and the right. Okay, so you guys know how to handle absolute value. And I guarantee you, on one of the free response problems, you're going to have to deal with absolute value. So if you deal with it by making a piecewise function, okay, good. If you just ignore the absolute value, then bad. But it's not right. Oh yeah, but you know what? They're going to make it where you got, just believe me. Just like this, people, just like this. What is the integral of 1 over x dx? What is that? Natural log, absolute value of x plus c. There's so many things that can go wrong here. You can forget the absolute value. You can forget the plus c. That would be very bad if you forgot either. Okay, next. Okay, you guys know the difference between continuous and differentiable? What? Okay, let's see if we can get it intuitively. Okay, here's 1, 2, and 3. Let's say you have a graph that looks like this. Woo! Okay, is this function continuous at x equal 1? Here's x equal 1. Is the function continuous?
No.
Yes.
Yes, continuous means, okay, Mr. Krause, you always say you can draw it without taking your pencil off the paper.
Differential.
Oh, it's not different.
Okay, continuous simply means there's no breaks in it, like a puka or an asymptote. Is this function continuous at x equal 1?
Yes.
Yes. Is this function continuous at x equal 3?
No.
No, because there's a puka there. Yeah, but I can draw it without taking my pen and the paper. But there's a break there. So what do we call this? What's the name of this called? Removable discontinuity. Okay, is this function differentiable at x equals 0?
Yes.
Here's x equals 0.
It's continuous and smooth.
Well, okay, well, differentiable means smooth and continuous. Is this function continuous? I mean, differentiable at x equals 0? Yes, it's continuous and it's smooth. So yes, it is at x equals 0. What about at x equals 1? No, it's continuous, but it comes to a sharp point. It's not smooth. So it's not differentiable at x equals 1. Is this function differentiable at x equals 2?
Yes.
Yes, it's smooth and continuous there. What about at x equals 3?
No.
No, because it's not continuous. These are two words you gotta know. Now, on the AP exam, okay, this is the last thing I'm gonna tell you today. Is this function continuous at x equals 2? Is it continuous at x equals 2?
Yeah.
Okay, yes. Then they're gonna ask you why. Okay, you put yes, you get 1 point. You want the other point, you gotta say why. Because you can draw it. No.
Because f of 2 is continuous.
Because the limit of this function as x approaches 2 equals f of 2. It's in your notes. Look at the definition of continuous. So if you don't refer to the definition when they ask you why or support your answer, you're not going to get the other point. Okay, the bell's going to ring already. Let's see if can we try and get up to number 7.
Wait, so starting tomorrow you're going to kick this off?
Yes. It doesn't matter what you did before. What matters is what you do now.
Wait, so if we get kicked out one day, you're not going to check the, and for the next day, you're not going to check the work that was due the day before, right? My homework is due that day.
You don't need it.
No, the days like that.
All you need is what I'm going to teach you now. That's all you need. There's no quiz tomorrow. I will tell you when the quiz will start. It's not starting tomorrow. Yes. Why, you're planning for something, Louis? Believe me, you can't get away with it.
I'm really right now.